It's no secret that water is a foundational element to our survival, and our communities depend on clean water to protect ourselves and our environment. When something threatens our ability to maintain that supply, we have to take action. Today, with the opening of the new Catharine Valley Water Reclamation Facility, we have ensured our communities clean water for decades to come.
Water's in our DNA. The lake is symbolic of what the people are that are here. Those that were born and raised here and those that move here, they move for the water. And so the lake is so critical for our survival. So having this facility and cleaning the lake and removing the nitrates, removing the chlorine, and actually just having a safer place for us to recreate, it's pretty critical.
Before the construction of our new joint facility, Watkins Glen and Montour Falls both operated separate treatment facilities. Operating since the 1960s, these facilities were aging, underperforming, and unsustainable. They occupied prime real estate and ultimately could not maintain the standards that we demand. But instead of simply building replacements for the old facilities, a new regional solution was developed. Combine the two plants into a single state-of-the-art facility that would serve both Watkins Glen and Montour Falls. This first-of-its-kind dynamic partnership between our two communities signals a new era of water security, and we're excited to show you how it works. Although the old treatment facilities are now decommissioned, the villages of Watkins Glen and Montour Falls still separately maintain previously existing wastewater collection systems. These collection systems consist of pipes that move raw wastewater from customer connections to the reclamation facility. With the previous treatment plants gone, the raw wastewater has to move from the separate collection systems to the new reclamation facility. This is done by pump stations and force mains, one in Watkins Glen and one in Montour Falls. The new pump stations each consist of a large concrete wet well structure that collects and temporarily holds raw wastewater, an underground valve vault that houses discharge piping, valving, and instrumentation, and a pump station control building that houses electrical and control panels. An on-site backup generator automatically provides immediate backup power in the case of an electrical utility outage. The new Watkins Glen pump station is located immediately south of the old Watkins Glen wastewater treatment facility. Raw wastewater is pumped from this station to the new facility via an approximately 5,000-foot-long, 18-inch diameter force main, or underground pipe. The force main runs down McGee Street, under Glen Creek, behind the Watkins High School, and then crosses under the Seneca Barge Canal. The new Montour Falls pump station is located immediately south of the previous Montour Falls wastewater treatment facility. Raw wastewater is pumped from this station to the new facility via an approximately 10,000-foot-long, 10-inch diameter force main. This force main runs north through the village Maria and then parallels the Seneca Barge Canal through the Catharine Creek Wildlife Management Area. Raw wastewater from each pump station and force main system enters the facility at the headworks room. Here, each separate raw wastewater stream from each village is metered through an electromagnetic flow meter before these raw wastewater streams are joined in a common pipe and discharged into the first step of the treatment process, screening. Wastewater passes through a cylindrical bar screen with quarter-inch spacing between the bars. Any materials larger than this are caught up on the screen and then mechanically removed and deposited into a dumpster. Public service announcement: never flush large or inorganic items down the toilet. This includes wipes that are marketed as flushable. Though this screening process is designed to remove these items increase the cost of maintaining the collection system and pump stations. After screening, the wastewater advances to a grit removal process. This process removes sand, grit, and gravel particles from the raw wastewater stream in order to protect downstream treatment equipment. Here, wastewater flows around a circular chamber. This circular flow induces a vortex, which forces heavier particles to the center of the grit chamber, where they settle out in a lower chamber. This grit is then pumped out of the grit chamber and into a grit classifier, which washes and dewaters the grit slurry and deposits the grit into a dumpster. The wastewater then flows into a sequencing batch reactor, or SBR process. The SBR is the heart of the treatment process, where microbiology and gravity perform the majority of the wastewater pollutant removal. The SBR complex has 3 parallel SBR trains, which allows for greater operational flexibility and ability to handle surges in incoming flows and pollutant loads. Each train has 3 treatment chambers where wastewater is processed in batches, with each batch progressing through a sequence of automated steps that utilize 2 primary treatment mechanisms. The first mechanism is biological in nature. Blowers introduce oxygen that microorganisms use to break down and consume pollutants. There are 4 60-horsepower blowers associated with the SBR process, 1 for each SBR train and a backup. Blowers pump air through piping, where it's mixed with a pumped wastewater flow through jet aerators to deliver oxygen and provide mixing. The second treatment mechanism is chemical in nature, with the help of gravity. A chemical called a coagulant is introduced that pulls together small particles, forming larger colloidal particles that are heavy enough to settle out of or be filtered from the waste stream. This chemical coagulation process primarily removes phosphorus, which greatly reduces the contribution wastewater treatment discharge has on algal blooms in the lake. Chemical storage and pumping infrastructure is located within the biosolids room. 2 1,500-gallon chemical storage tanks receive monthly coagulant deliveries, and peristaltic metering pumps pump the coagulant from the storage tanks to the SBR process via chemical feed piping. At the end of the automated SBR treatment sequence, the pump and blowers are turned off, and the biological and chemical solids settle to the bottom of the treatment chamber. The remaining treated water is then drawn off the top of the tanks and discharged to equalization tanks. From the equalization tanks, the treated wastewater is pumped into the effluent filtration and UV room for final polishing and disinfection. Effluent filtration consists of 2 parallel cloth media filters. Each effluent filter has 10 6-foot diameter discs mounted to a central axle. Each disc supports a cloth media. As water flows into the filter tanks, it passes through the cloth media and out of the filter unit. Small solids are trapped on the outside of the filter media. Solids are then removed from the filter through an automatic backwash cycle and are discharged back to the head of the SBR complex. After effluent filtration, the treated wastewater passes through an ultraviolet, or UV, disinfection unit. Here, UV bulbs inactivate any microorganisms remaining in the treated effluent. The UV disinfection system is a non-contact system. Water passes through a series of tubes located within the UV unit and does not come into direct contact with the bulbs. The effluent filtration and UV room is designed with space for a 3rd cloth filter and 2nd UV unit for future expansion. After effluent filtration and UV, the reclaimed water is discharged to the canal. The treatment process, unsurprisingly, results in waste in the form of biosolids, of which we need to safely dispose. These solids, commonly referred to as sludge, include microorganisms, particles from the chemical coagulant, and other inert solids. Sludge is pumped out of each SBR train and temporarily stored and conditioned in aerated fiberglass storage tanks located inside of the biosolids room. Sludge is then mixed with a chemical called a polymer and is pumped into a screw press that mechanically squeezes the water out of the sludge in order to make it ready for off-site disposal. One of the defining features of the new facility is the Advanced Central Command and Operations Center that houses staff, laboratory operations, and a maintenance shop. The facility employs 4 operations staff that operate the facility, conduct the required daily sampling and monitoring, and maintain the treatment equipment. Operators are required to collect and analyze samples daily in order to meet regulatory requirements and monitor operational control parameters. Though some compliance samples are sent off-site, the facility operators can conduct all operational control analysis at the on-site laboratory in order to save laboratory costs. The maintenance shop has also been set up and equipped to maximize the amount of in-house maintenance staff can perform in order to minimize third-party maintenance and repair fees. The overall treatment process is controlled and monitored by a SCADA system. SCADA stands for Supervisory Control and Data Acquisition. The SCADA system integrates all process equipment into a single controls platform that can be accessed from any treatment process building, operator workstation, or the laboratory. The SCADA system provides the information needed to optimize operation and quickly identify and remedy upsets before they become a compliance issue.
Here we are today, 9 years, and $32 million later, proudly cutting the ribbon for the new Catharine Valley Water Reclamation Facility.
The opening of this new facility is the culmination of 9 years, $32 million, incredible engineering, and spirited collaboration. It's a testament of our commitment to each other and environmental sustainability. It's an engine to economic growth and regional prosperity. Simply put, it's the future, and the future is open.